Let me try to record a video so those missed class, the student missed class, they can watch the video on Blackboard. Okay, chapter 13 homework. Let's take a look. Question 16. Question 16. Oh no, chapter 13. Wrong place. Okay, question 16. Calculate the molarity of each of the following aqueous solution. I just show you one. Okay, A 2.5 molar sodium chloride solution. The density of this solution is 1.08 gram per milliliter. Chapter 13, question 16a. 2.5 molar, that's a molarity. NaCl solution. Tell you density of this solution is 1.08 gram per milliliter. As you calculate molarity, we use lowercase m. Okay, first of all, do you understand this is a question? NaCl solution. Here your molarity is 2.5 molar. 2.5. And density after you calculate molarity. Then first of all, what is the difference molarity and molarity? Do you remember? Molarity M is more divided by liter of solution. Right? And what is molarity? Is more. More means solute, right? Divided by kilogram of solvent. So the difference is denominator. Molarity is divided by liter of solution. Molarity is divided by kilogram of solvent. Okay. Again, numerator exactly the same. So how can we solve this problem? I mean, assume we have one liter solution. If we have 1 liter solution, according to this 2.5 molarity, 1 liter solution, then moles of NaCl will be 2.5, 5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2.5, 2 NaCl will be 2.5 molarity times 1 liter will be 2.5 more, right? Then this 2.5 more, this is solute, right? We can use this. The risk becomes, in this 1 liter solution, how many kilograms of water there? Aqueous solution solvent is water, right? So this is a actual problem solving. How many kilograms of water in 1 liter of this solution? 1 liter solution, you want to figure out how many kilograms solvent, water as solvent. Then, do we know total mass of this solution? Yes. We have density, right? So mass of 2.5 molar NaCl solution actually mass of 1 liter. Mass of 1 liter, because we assume it's 1 liter, right? Mass of 1 liter is solution. We have volume, we have density is mass, right? So 1 liter is 1,000 milliliter because this density is gram per milliliter. That's why you need to convert 1 liter into 1,000 milliliter. Milliliter cancel this per milliliter, right? So the mass of solution is 1080 gram. This includes sodium chloride plus water, right? Solution is solvent plus solute. And solute, we already know moles, we can figure out mass. Then solution mass minus solute is solvent. Okay. So mass of sodium chloride, which is solute, will be 2.5 more multiplied by what? More multiplied by molar mass, right? You get a mass. What is the molar mass? You need to use periodic table. Sodium 22.99. Chloride 35.45. Together will be 58.5. 58 point, more accurate is 0.44 gram per mole. Again, find out this molar mass with the help of periodic table. Okay, sodium 22.99, chlorine 35.5, together 58.44. So this you get mass of sodium chloride will be 2. Do you have a calculator? 2.5 times 58.44, 140, less than 50.
I got 146.1.
Yeah, okay. 146.4?
0.1.
0.1, okay. Okay. Then from mass of sodium chloride together mass of solution, we can easily find mass of water. Because mass of solution minus mass of sodium chloride. Mass of solutions is 1080. Mass of sodium chloride 146.1. Then 934. 33.9. Right. we have 0.1 there. 933.9 gram of water. And this molality is a kilogram, right? We just convert this gram into kilogram. Become 0.9339 kilogram. Then molality equals the moles of sodium chloride divided by kilogram of water. Moles sodium chloride 2.5. Kilogram water is 0.9339. Then your molality will be 7.82. Since this is 3 significant figure, this is 4, so your answer cannot have more significant than any of the original number. So just keep 3. 7.84, 7.82. So molality is much different with molarity. Okay. For the concentrated solution. Oh no, the 2.68, sorry. Because this is a close to 1. It's 2.68. So. Are you okay with this? Let's take a look. Next one, number 20. The concentrated sulfuric acid we use in lab is 98%. As you calculate the molality and the molarity of the acid solution. Tell you the density is 1.83 gram per milliliter. Concentrated sulfuric acid we use in lab is 98%. This 98% is mass percent. In other words, if we have 100 gram of this solution, you will have 98 gram H2SO4 plus 2 gram water, because this aqueous solution is water, right? Solute is H2SO4, solvent is water. So in 100 gram of solution, you have 98 gram H2SO4 plus 2 gram water. It's a mass percent. Also tell you density of this solution is 1.83 gram per milliliter. As you calculate molarity and molality. Okay. Yeah. Molarity and molality. Since this is a mass percent, it means in 100 gram of solution, you have 98 gram of H2SO4 plus 2 gram of water. So we just assume we have 100 gram of this solution. The rest we based on this assumption we can calculate. Okay. So 98 gram H2SO4 plus 2 gram water based on this 98%, right? Then from 98 gram H2SO4, we can easily convert to more, right? Molarity is more divided by volume in liter, right? So we definitely need more. So more of H2SO4 will be 98 gram divided by molar mass. What is a molar mass? Use periodic table. Right. So hydrogen is a 1.008. It's simply just a 1.1. Okay. Sulfur 32. Oxygen 16. 64, 96, 98. Right. 98 and 98 is one. One more. So molarity is moles divided by liter. So next we need to figure out the liter. What is a liter? We have mass. We assume we have 100 gram of solution. And we have density. Of course, we can calculate the volume, right? Because density is mass divided by volume. Then volume equals to, we just use V. Volume equals to mass divided by density, right? Because density equals to mass divided by volume. We just switch volume with density. Okay. Mass is 100 gram. Density is 1.83 gram per milliliter. Okay, so this we get 54.6 milliliter. Convert this into liter because molarity is more per liter, right? Convert the milliliter, mole 3 decimal place. Divided by 1000. 0.0546 liter. Right? Then molarity equals to more divided by liter. Molarity is more divided by liter. More about 1 liter, 0.0546. Use calculator. 18.3 about. This is molarity. Okay. The molality is more divided by kilogram of solvent. More is the same, right? And we need to figure out a kilogram of solvent water. 2 gram water. 2 kilogram is mole 2 decimal place, right? 3 decimal place divided by 1000. 3 decimal place, 0.002 kilogram. Then we can calculate molality. So molality is moles of H2SO4 divided by kilogram of water. Or more is here. 1 kilogram is here. 0.002. 500. Okay, so molarity 18.3. Molality is 500, much different. Let's take a look at another one. 49. Vapor pressure of benzene is 100 millimeter mercury at 26.1. Vapor pressure of benzene is 100 millimeter mercury at 26.1 degrees Celsius. As you calculate the vapor pressure of a solution contains the solution this benzene. A solution contains 24.6 gram chemical C10H16O. In 98.5 gram of benzene. As you calculate the vapor pressure of this solution. What is the vapor pressure of this solution? So this vapor pressure is just the pure benzene. Of course, we assume this is ideal solution. Okay? Do you remember ideal solution? What is the vapor pressure of the solvent? So this C10H16O is a solute, not volatile. This means will not be vaporized. Just like a sodium chloride, will stay in solution. So only solvent will vaporize. Solutions vapor pressure equals to pure solvent vapor pressure, which is actually this pure solvent, times mole fraction. That's right. This mole fraction is mole fraction of solvent or solute. Since ordinary solvent vaporize, solute stay in solution. Of course, this mole fraction is solvent mole fraction, not a solute mole fraction. When you dissolve some solute in solvent, it becomes solution. Solvent mole fraction always less than 1. Then this vapor pressure will be always smaller than this. So since this is a non-value, so what we need to do actually is just mole fraction of solvent. So more is mole fraction solvent. Mole fraction of solvent is moles of solvent divided by total moles. Since here tell us mass, we can easily calculate the mole, right? Mole divided by molar mass. So mole of C10H16O equals to mass 24.6 gram divided by molar mass. What is the molar mass? Use this formula with the help of periodic table. Okay, so 10 carbon, each carbon is 12. 16 hydrogen, each hydrogen is 1. 1 oxygen is 16. Right, this is molar mass. So mass divided by molar mass, we get moles, 0.162 mole. The mole of benzene equals mole of mass of benzene, 98.5 gram. Benzene formula is C6H6. Don't worry, in the test, I will provide the formula. And I will provide your periodic table. So C6H6, each carbon is 12, each hydrogen is 1, so total is 78. This will be 1.26 mole. Then mole fraction will be moles of solvent, 1.26, divided by total moles, 1.6 plus 0.162. Then use this formula. Vapor pressure equals to vapor pressure of pure solvent, 100, times mole fraction of solvent, 0.886, 88.6. Are you okay for this one? Let's show you one more. 71. Number 71. Ask you normal freezing point and boiling point of the solution. I'll just show you one. The 8. The others will be similar. Okay, let's show you solution 8 is 21.2 gram of sodium chloride in 135 milliliter of water. And the 1.2 gram sodium chloride dissolved in 135 milliliter of water. Ask you what is a normal boiling point and freezing point. Oh, you realize this is a colligative properties. Boiling point, elevation. What is the formula? I times Kb. Kb is a constant. For water, Kb is 0.52. I will provide you a table during the test. Okay. Kb, Kf, I will provide a table. So I, what is I?
Forgot what it was called, but I know for NaCl it's equal to 2.
Yes. NaCl in water break down into 2 particles. So this I is 1 plus 1 is 2. The I is the number of particles from 1 unit of the solute. So I times Kb times molality M. Right? So I is non-value is 2. Kb is a non-value from a table I will provide you. Okay. So what you need to do is just M molality. Then delta TF also I times KF times M, right? I is non-value same. KF from the table provided, you can find it. So for water, KF is 1.86, KB is 0.52. Anyway, from the table provided, you can find the KF, KB. Then what you need to do is just find M, right? M is molality. So both boiling point, freezing point, you need to find out molality. Then from delta TB and delta TF, we can convert it back to TB and TF. Delta TB is TB minus TB0. TB is higher than pure water's TB. Delta TF is TF0 minus TF because the solution's TF is lower. Right? Solution's boiling point is higher. Okay. So anyway, oral conditions here. So 10 day 1.2 gram sodium chloride dissolved in 135 milliliter water. What you need to do is figure out the molality. Then we can calculate the delta TB, convert the TB, calculate the delta TF, convert the TF. Right? So critical things, try to find M molality. Molality, moles divided by kilogram water, right? Didn't tell us moles, but tell us mass. So moles of sodium chloride is mass divided by molar mass. Sodium chloride use periodic table. Sodium 22.99, chloride 35.45. Together at 58.44 gram per mole. So from here, this equal to 0.363 mole. Then molality M is moles divided by kilogram of water. 135 milliliter, not a kilogram. Water is 1 milliliter is 1 gram. You know this. Water's density is 1 gram per milliliter. Then 135 milliliter is 135 gram. Right. Okay, so 135 gram converted to kilogram is 0.135 kilogram. Divided by 1,000, right? Both 3 decimal places. So it's here we get molality will be 2.7. Then delta TB is I times KB times M. I, like I explained here, this I is 2 particles every unit. Sodium chloride dissolved. So this is 2. KB from a table provided is 0.52 for water. Celsius degree per molality. Then times 2.7 is molality. So this will be 2.8 Celsius degree. So from delta TB, then what is TB? Because delta TB is TB minus TB0. TB0 is boiling point of pure water. Okay, so from here, TB will be move this minus TB0 to this side. So TB equal to TB0 plus delta TB, right? TB equal to TB0 plus delta TB. TB0 is boiling point of pure water, that is 100 degrees Celsius. Do you remember this? This is a very common number. Okay. Pure water with boiling point is 100 degrees Celsius, and the delta TB is 2.8. Then together is 102.8 Celsius degree. Okay. Now we calculate the delta TF. Delta TF is I is the same, right? The same as 2. KF, from the table I will provide, the water's KF is 1.86 Celsius degree per milliliter. This is 0.52 Celsius degree. And times milliliter is 2.7. This will be 10 degrees Celsius. Okay, I used to miss this Celsius degree. Okay. KB for the water is 0.52 Celsius degree per milliliter. Okay. KF for water is 1.86 Celsius degree per milliliter. Okay. So overall, delta TF will be 10 degrees Celsius. While delta TF, the actual meaning is TF0 minus TF. Solutions TF is lower than pure solvent TF. So delta TF means TF0 minus TF. While delta TB is TB minus TB0. This is the opposite. Because solution's boiling point is higher than solvent. And solution's melting point is lower than solvent boiling point. That's why this is the opposite. You need to be careful. So from here, your TF will be TF0 minus delta TF. Right? Move TF to this side. Move delta TF is this side. TF0 for water is 0 degrees Celsius. And the delta TF is 10. Minus 10. 0 minus 10 is negative 10. So freezing point of this solution will be negative 10 degrees Celsius. Are you okay for this one? Do you have any other question? No, no.